When you really take time to break some things down that seem simplistic, like matter, thoughts, how the world rotates on its axis, and even something as overlooked and simplistic as fire, you will see that those things are very complex. Those things helped evolve our civilization to what it is today. Like, for instance, think of coffee. Coffee was discovered by a goat herder. But what has coffee done for our civilization? Well, your brain has adenosine receptors, which is a neurochemical transmitted towards your brain that makes you tired. But when you drink coffee, it blocks adenosine from leaking out and making you tired. And that's why if you are an avid coffee drinker like myself, the more coffee you drink, the more adenosine receptors your brain builds, which means more adenosine leaks out, and you have to drink more coffee in order to temporarily block that from leaking. And if you don't, for around a week, you'll be more tired because more adenosine will leak out. And when people in Western civilization started drinking coffee to keep them up, they were able to work longer hours because of the adenosine receptors and get more done. And they started coffee shops where they started talking about politics and current events. And you can make the case that because of coffee, which most people take for granted, that they started drinking it at those coffee shops and they invented things like math, philosophy, and science. And they were able to stay up longer. The other thing which I think really has helped civilization is fire. And when you break it down to its simplest form, fire is a few simple things. It's oxygen, so the oxygen around you and what you breathe out. But with that oxygen, you need fuel, which is wood, gasoline, methane, something to light, to fuel the fire. And then you need heat. And that can be from friction that you use with a match or an electrical spark that releases energy. Then you need oxidation. And oxidation is basically interaction between oxygen molecules and something else. Something will lose molecules. So if you have something that's iron, over time it will lose oxygen and start to rust, and that's called oxidation. And oxidation is basically exposure to oxygen. So when heat is added to fuel and oxygen, eventually the fuel source will lose electrons and oxygen will gain them. This transfer creates heat and light, which is fire, basically. And as the fuel, which in most cases is wood, heats up, it gives off gas. And the gas escaping is what is being lit on fire, not so much the actual wood. So when you light wood, the gas that's escaping the wood is what is lighting the flame. The wood is just the fuel for the fire. Once the oxygen leaves the wood, what you mostly see is carbon. So when you see charcoal in your fire, that's carbon. So when the fire is done, you see the ash and the impurities that can't burn. And that's mostly potassium. But once the fire is going, it gives off heat, and heat helps the fire continue to burn. To pour more oxygen out of the wood as the heat cycles the air around, the flame produces more gas. And if you notice when you have a fire, if you start a big campfire, flames always seem to go up. And that's because they are more dense than the air, which means they have more energy than the air around them. And they have more energy. So they try to move up to cool off and get a lower pressure. But then under you have cool air that comes underneath. And this is why fire spreads upwards. So as complex as fire is, and the fire triangle, all the things you need to start it, it's pretty simple to put it out. You can use a fire extinguisher, which contains CO2, and it removes the chemical reaction. But basically, when you break it down to its simplest form, fire is a chemical reaction that releases heat into the air. But then you start thinking fire didn't always exist on planet Earth, because there was a time when oxygen didn't exist in the Earth's atmosphere. And without oxygen, there's no fire. But 2.3 billion years ago, you had the Great Oxygenation event. And after that, we had oxygen, but we still didn't have fire. There was still no fuel for the fire to burn. The earliest fuel would have most likely been plants. There was a study on the Wonderwork cave, and scientists took soil samples from the cave. Under the microscope of those samples, they found carbonized pieces of leaf and twigs. They also performed a test, which basically saw how hot it got. And the test showed that the material in the cave had been heated between 750 and 1300 degrees Fahrenheit. And that lines up with a twig campfire. But we're still not 100% sure when humans made the first campfire. We're not sure if it was humans that made that fire. That was over 1 million years ago. But the oldest evidence that we know of from the first controlled fire, which humans could control, means that we harnessed the power of the fire, was in Israel. Because the evidence, we found fire and seeds from the fire. And we found ash and evidence of a hearth. And a hearth is small places to cook before the fireplaces existed. And that was found over 17,000 years ago. But even though scientists don't know for sure when the first fire was found, they do know people used it to cook and warm themselves. So think about this, kind of like coffee. When you cook food, it breaks down the proteins, so you don't spend the entire day chewing. Just like cows, they chew cud, which is grass, and they spend the entire day chewing. But if you spent the entire day chewing, then you wouldn't be able to invent the will and progress Western civilization. Also, you could use fire to keep you warm at night, and you could use it as a light. So you could help guide where you were walking, or you could stay up later and perform more tasks. So even though most people don't think of these complex things, without coffee and without fire, our civilization would not be the same it was today.